Hi folks, and welcome back to Math with Captain Rod. I'm making this video here to provide yet another example of how to sketch graphs of parabolas. So here's an equation here that represents a parabola, and what we need to do, or one way to graph it I should say, is to take this and put it in its standard form. Once it's in its standard form, we will know the vertex. The vertex will be the point HK. And that's usually the beginning point of graphing these things. So let's go ahead and start doing that. So I'm going to take this y equals minus 2x squared minus 4x plus 5. All right, now when you complete the square, you want this term right here to be a 1. So a good first step here would be to divide everything by negative 2. So this is going to read y over negative 2 equals, this is now going to be x squared plus 2x. Let's see, 5 divided by negative 2, that's going to be minus 5 halves. We go, uh-oh, fractions, and it happens from time to time. All right. Now, when you complete the square, you focus on this stuff. So what you typically do is make a little room here. I should have just written this over here. I'm going to just kind of move this off to the side. And completing the square is all about what's happening here. Next line. So y over negative 2 equals, again, the idea is we want to write this as x plus something, the quantity squared. Now, remember when you FOIL, the outer and inner terms have to give you a 2. So this term will always be half of this. So this is 2, halving that will be a 1. Remember though that when you FOIL this, the very last term, like if you were to take x plus 1 times x plus 1, the very last term will be 1 times 1, which is 1. And we don't have a 1 there right now, we have nothing. So I'm going to go ahead and just put a plus 1. This is the step that makes this exactly equal to this. But you can't just add a plus 1 on the right hand side. We either have to add another 1 to the left, or we can just come over here and subtract 1. Now we've maintained equality, and that's what I would do here. Let's just do that. So this is now exactly equal. This and this exactly the same thing. Now we'll simplify over here. Let's see, minus, now let's see, common denominator. We can think of this as 2 over 2. So negative 5 minus 2 is negative 7 halves. Make sure I did that right. So again, common denominator here, this 1 we can write as 2 over 2, so that's negative 5 minus 2, and then all over 2. So I think we're good. All right. Now what we do is we take this negative 2 and just put it back on the other side by multiplying. And when we take, let's see, negative 2 times this, the result will become positive, and then the 2's will cancel. All right, so look at what we have here. We have our original equation rewritten in its standard form. You notice that a is negative, so we know this thing opens down. Okay, the vertex. Now we just compare this. Let's see, x plus 1 to x minus h. So the h has to be negative 1. And then we compare the plus k to plus 7. All right. So what do we know now? We know that the vertex of this parabola is at the point negative 1, 7. And again, remember from our discussion about translations, you know, if we kind of compare this function to y equals x squared, I'm going to do that real quick. Just kind of do a quick comparison here. Remember that this x plus 1 would shift it left 1, and that's why we've got this minus 1 there at the vertex. Remember that the negative 2 here, the minus sign will reflect it about the x-axis, right? That's why it opens down. The 2 will change its shape vertically, and the 7 will lift it up 7 units. So just a quick reminder about function transformations or translations. All right, so let's start graphing it. So negative 1, 7 is 1 to the left, and then 1, 2, 3, 4, 5, 6, 7 up. There we go, 7 up. I'm getting thirsty. Let's go ahead and plot or label that negative 1, 7. There's our vertex. We'll get the x-intercepts in a moment. Y-intercepts are usually very easy to get for parabolas. Look back to the original here. If you put in x equals 0, these terms are gone and we just get y equals 5. So let's go ahead and put that one in there. 0, 1, 2, 3, 4, 5. Looks very similar to the last example I did. This problem is symmetric, or parabolas are symmetric, so this point right here also has to be there. This thing must also go through negative 2, 5. All right, let's go ahead and look for the intercepts. Now we can do that a couple different places. We can either put a 0 here and apply the quadratic formula, or we can put a 0 here and solve for x. I'm going to go ahead and do that. So we got 0 equals negative 2 times x plus 1 squared plus 7. We would then subtract the 7. Divide by negative 2. And since we're going to be doing this for graphical purposes, I'm just going to go ahead and put 3.5 here instead of 7/2. Right, and this is coming from negative 7 divided by negative 2. There's our 3.5. Now, we solve this by taking the square root of both sides. I'm running out of room. I'll write this over here. So one possibility is that x plus 1 is equal to the square root of 3.5, or x plus 1 is equal to minus square root of 3.5. Now, if we solve this one for x, we get square root of 3.5 minus 1. I'm going to go ahead and just get a number out of that. I get 0.87 out of that. I'm rounding a little, but that's all right. We solve this one for x, we get negative 1 minus square root of 3.5. I get negative 2.87. Let's just call that about 2.9. Again, approximately. These are just sketches, so they don't have to be perfect. All right. So 0.870, so here's 1. 0.87 is a little short of that. Let's put that one here. Negative 2.9, so 1, 2, 3, a little short of that. All right, there's our parabola. So we can now sketch it. That's good enough. All right. Let's discuss some of its properties. All right, the axis of symmetry. The parabola is symmetric about this axis. The equation for that axis is x equals negative 1. Domain and range is always important for functions. Write this over here. Domain, all real numbers. Okay, folks, I mean, here's kind of a reality here. The domain of all parabolic functions like this is all real numbers. You can always put anything in for x you want. You're going to get a value out. Okay, the range of this function. Notice that the highest y value here is 7. All other y values are less than that, so the range is y less than or equal to 7. So, there's an example of sketching a graph of parabolas, and I can't think of anything else to talk about. So I hope you enjoy these videos. Have a great day.